So today we are going to be starting the quadratic function unit, unit 4. And the first thing we're going to talk about quadratic functions, is being able to identify solutions of a quadratic function, the vertex from either a table or a graph, and decide whether that vertex is called a minimum or a maximum. So first, let's talk about what solutions of a quadratic function are. And remember, if I'm writing too quickly for you and you need a little bit of time to catch up, you can always pause this video. So the solutions of a quadratic function are the values of x that make the function equal 0. These are also called zeros because they're what make the function 0. Roots, or x-intercepts. Depending on the book you're reading or the teacher or the person that's talking, the solutions might be called any of these things. Some people call them roots, some people call them zeros, some people call them solutions, some people call them x-intercepts. But all of these mean the same thing, the places where the function equals 0, the values of x. So for example, if your quadratic function looks like this, going to make one up. And I know this is a quadratic function because it has this squared right there. That's the biggest exponent, so it's a quadratic function. Let's say my quadratic function looks like that. The solutions would be whatever x could equal, turn that into 0. Whatever x will be to make that equal 0 if I simplify it out. Those are the solutions. The vertex is another point on, or another important feature of a quadratic function, and it is the point in the function where the y values change direction. So for example, if your function is going down and then it starts going back up, that point down there where it changes direction, that's the vertex. Or if it's going up and then back down, that point right there where it changes direction is called the vertex. So that's the vertex, or that's the vertex. The point where it changes direction. If you think back to maybe like elementary school or intermediate school, and they talked about symmetry, it's the place where your function would fold in half and be symmetrical. So maybe we could also think of it as the folding point. If you folded the function right there, it would land on top of itself. Or right there, it would land on top of itself. Now the minimum and the maximum is just really a more specific way to talk about the vertex. If the vertex is the low point, remember you can pause this video to write to catch up if you need to. If the vertex is the low point, we call it a minimum. So in this one right here, we would call the vertex a minimum because it's the lowest point on the function. If the vertex is the high point, we call it a maximum. So for example, in this one, because the vertex is the highest point of the function, we could call the vertex the maximum of this function. So now let's look down here and we'll try to identify these different things. If we look at this first graph, that's the vertex, the highest point of the function. And because it is the highest point, we can call it a maximum. And the solutions, remember, are the values of x that make the function equal 0. So this is where the function zeroes out, right along the x-axis. That's when the y value is 0. We put a 0 right there. So the solutions would be x equals 6 and x equals 8. So I will write solutions x equals 6, x equals 8. Those are the x values that have a y value of 0. They're the x-intercepts of this function. So there are two solutions here because there are two x-intercepts. A quadratic function will never have more than two x-intercepts. It's always going to go up through it and then down back through, or down and then back up. Or it could just have one or none, like we'll see in a couple examples here. In this function, it looks like our vertex is down here at 1, 2, -3, -2. I'll write the vertex here. The vertex is 7, 1. Here the vertex is -3, -2. And that is a minimum point. And I have two solutions here. It looks like it's -1.5 and -4.5. Oops, -1.5, -4.5. Okay? Now let's look at this graph. Our vertex is happening right here where it's changing direction. So that is happening at the point 1, 0. And it's maximum. And it looks like we just have one solution here because there's only one place. There's only one x value where the y value is 0, going this way. And that is right here at the point, well, we'll say the solution down here is x equals 1. When the value of x is 1, the y value is 0. Over here, the vertex is right there at the point 1, 3. And that's a minimum point. And there is no solution. We'll say that there's no real solution because in Algebra 2 you will learn about a different type of solution that this function has called an imaginary solution. But for Algebra 1, there is no real solution to this function right there. There's no place where it crosses the x-axis. There's no x value where the y value is 0, which is the x-axis. Now let's look at the table. If we follow the table, the place where the y value changes direction is the vertex. So here it goes 6, down to 5, back up to 6. This place right here in the middle where it changes direction is called the vertex. It's also the folding point of the function. If you were to fold these values down here up onto these values up here, it would cross. Like they would land on top of each other. The 6 would land on the 6. The 9, if we were to go up farther, the next value would be a 9. The next value would be a 14. That's like the symmetrical point of the function. So this is the vertex. Because they're going down and then back up, that means our graph is going to look something like this. Down and then back up. It's going from 6 down to 5, back up to 6. So we know that that's a minimum point. And this function does not have any x-intercepts. If we were to graph it, that's a 6, that's a 5, that's a 6 for the y values. That means the x-axis is way down there. So there are no solutions to that one. Let's go to this one. We have -3, 0, down to 1, or sorry, -3, up to 0, up to 1, back down to 0, back down to -3. So this is the folding point of our function. This is the vertex right there. You can also tell because like 0 would kind of map up onto 0, -3 would map up onto -3. This is like the folding point of our function. If all of these were to fold up there onto those, they would land on top of each other. They would match. So that's the vertex. If you kind of just imagine where these would be plotted, the y value would be -3, 0, 1, 0, -3. So that means that the vertex is a maximum point, and there are two solutions. There's two x-intercepts because remember the x-intercept happens when the y value is 0. That's happening there and there. So my solutions are x equals -3, x equals -1. Over here, we start at 0, we go down to -5, and then back up to 0. So this is like our middle spot of the function where it's changing direction. So that is the vertex. If you think about what that function looks like, it's starting at 0, it's going down to -5, and back up to 0, and then 15 and 40 and so on. So we know that that vertex is a low point, so it's a minimum. And then my solutions are just the x-intercepts, and that happens here when this y is 0 and here when that y is 0. So my solutions are x equals 7, x equals 9. And then this last one over here, we're at -4. We go up to -1.5. So if I think about what this looks like, I start at -4, just the y values here, up to -1.5, 0, 0.5, back down to 0. I'm just plotting these y here, these points. So my vertex is a maximum point up there. Okay, that's like my folding point of the function. I go up, 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 and then back down to 0. So this is where I change direction right there. And it's a maximum. You can see from our sketch here that that's a maximum. And the solutions are the x-intercepts, which are here and there. Those are the two places where y is 0. So my solutions are x equals -1 and x equals 1. So that is a summary of how to find the solutions, the vertex, and the minimum and maximum of quadratic functions when they are graphs and when they are tables. Thank you for watching.